let's get started. So if you're new to forward education, it's super exciting to explore and to learn more about robotics. Forward Education was founded in 2016, and we have a whole suite of activities and kits that you can use to teach coding and robotics, as well as with AI. Teaching coding for the first time can be exciting, but it can also feel overwhelming. So it's really great that Forward Education has a whole learning platform of activities that can help educators navigate those feelings of overwhelming and then make you feel more confident. So you're better able to explore a hands-on activity with students and not just learn about what a program does, but feel and be able to explain how it actually works. So it's great that everyone is sharing where they're coming from, their location, what their experience is. We'll explore some of those pieces together today and then learn about the platform. Our products all use microbits, which is a global tool that is available. There's over 2 million microbits deployed in K-12 schools in the US, and 85 countries around the world are learning with microbit. So it's a great platform to expand off of using something like Forward Education's breakout boards and the kits that we have available. One of those kits that we have is the Climate Action Kit. It makes coding easy to implement around the platform. There's tons of different sensors that are available, as well as building blocks. So we'll explore some of those pieces today, as well as projects that you can build with the Climate Action Kit. We recommend that you have a student ratio in your classroom of 1-to-1 or 2-to-1, and there's lessons and activities available for grades 3 to 12. We're also super excited to talk about the Climate Action Kit as well as the Coding for Good Kit. So the Coding for Good Kit is our newest kit. It has expanded sensors and real-world projects. Everything in the Climate Action Kit is also in the Coding for Good Kit. And there's 4 new sensors. So I've got a Coding for Good kit available here with me today. We'll take a look at. It's fully compatible with the Forward Education learning platform, and kids are able to learn critical thinking and apply coding for real-world problems with that kit. So super exciting. We're going to preview some upcoming projects and lessons with that Coding for Good kit. So here's some right now. We have a motion sensing light detector. We've got digital color sensing and sampling. We can test soil temperature. We can make an entry alert monitor, as well as a smart recycling sorter. So I have some projects with me right here. Here's an example of our built motion sensing lights. So we have our new LCD display where you can type anything you want, any characters on that actual display. And we have our motion sensor. So when someone walks past your door or your desk, it will give you a bit of an alert, and it will be able to tell you what's going on. So those are using 2 of the new sensors in that Coding for Good kit. I also have a built smart recycling sorter, which is a super cool project. So we've got, again, our LCD display here, and then we're using a color sensor that can see red, green, and blue. And when we see blue materials, those are going to be sorted into our recycling bin on one side using our servo, and on the other side, we will have our garbage or non-recyclable materials dive into that side. So these are some projects with activities coming soon using some of those kits and sensors from the Coding for Good kit. I talked a little bit about the expanded sensors in the Coding for Good kit. So we took a look live at what that color sensor looks like. Our color sensor detects colors and the intensity of light. The PIR sensor in this kit is a motion sensor, so like our smart entry. We'll take a look at that. So it's a square sensor, our motion detecting. Then we also have a temperature probe. So your temperature probe in the Coding for Good kit is waterproof, and you can take the temperature directly for different things like soil. You can also take the temperature of water. It's waterproof. So there's lots of great opportunities to connect coding concepts with life sciences, as well as chemistry, with the ability to have that temperature as well. And the LCD display, you can show real-time data on a display larger than the microbit. So we're super excited about all of those new opportunities. The Coding for Good kit also comes with more motors so that you're able to create more dynamic projects and expand with additional building blocks. So this is something that comes and enters really easily into the ecosystem with Forward Education. And we've got all of these expanded activities on learning resources in that learning platform. So our learning library, our lesson library, has more than 200 hours of curriculum-aligned learning content, and it's linked to career skills, role models, and career profiles with each one of those lessons. It also has an example of a real-world context. So we'll take a look at what that looks like on our learning platform, and I'll encourage you to follow along as well. We have webinars like this that you're able to join. We also have self-guided educator training. So there's teacher courses and guides that you can use in your classroom if you're looking to refresh something asynchronously as well. We also have connections with different groups. So there is connections and a library of North American Indigenous perspectives that are connected directly to career role models. So there is something for everybody in that platform, and it's all easy to download and code with and to deliver any lesson content in your classroom. So our ecosystem helps to have plug and play blocks and sensors. It's simple and easy to use with the platform of tools. Our learning resources have the connection across different aspects of the curriculum. So whether you're teaching computer science, math, science, any other connected real-world activities, there is something that you're able to find direct connections that are curriculum aligned to your grade level. And we offer educator training and ongoing skill building to be able to scale capacity. So we've got lots of opportunities, both synchronous and asynchronous. With that, let's take a look at our learning platform. So I would love for you to go to learn.forwardedu.com. And what we're going to do together is take a look at how we're going to create an account and view our dashboard. We will explore projects, tutorials, and lessons based on your interest or the kits that you have. And we're going to figure out some tips and tricks as we go through that's going to help you deliver your content with students. So with that, let's take a look at our learning platform. We're going to go to a new tab. Okay, so we're going to go to learn.forwardedu.com. And if it's the first time that I'm going to my learning platform, I'm going to see an account preview like this. So educators are encouraged to create an account. Our entire learning platform content is free. There is no paid requirements, and you have all of the access to all of the content on our learning platform. You want to create a free account so that you're able to share all of the resources with students in your class through some easy link sharing that we'll take a look at as well. So if I'm creating a free account, I can click this button. If I already have an account and I'm coming back after a while, I can also click this login button. There's easy ability to sign up or log in with Google or Microsoft, whatever your school board might have. You can also send a login email for another project. So I'm going to log in with my email. And then we're going to see what our platform looks like. So I'm taking a look and showing you live. I'd love for you to follow along with me as well. What we see here is our dashboard of featured lessons as well as featured resources. So we see that there is a lesson library full of different content. We also have educator resources that can help us to connect or expand some of those pieces. And we have some tutorials and projects. So let's take a look first at some sample projects. A lot of people who've joined today have a climate action kit and we're learning for the first time. I'm going to recommend some of these featured lessons in our lesson library. So let's click View Lesson Library, and we're going to find a lesson that's related to a topic that we are teaching right now. On our lesson library and in all of the content on the learning platform, Forward Education has several kits that all integrate together. If we just have our Coding for Good kit or our Climate Action kit, we're going to search by and filter for the kits that we have. So in this example, we can use our Coding for Good kit or the Climate Action kit, and we're going to filter by the lessons that are using the kits available. If I'm teaching a specific topic for a lesson, so for example, if I've just started a life sciences unit, or if I'm talking or introducing concepts about energy and renewables, I can filter by those topics as well in my classroom. Finally, with lessons, there's grade alignments that we can add some filtering as well, or we can look at the colors related to those icons within the lesson library. If I'm looking for a direct connection that's curriculum aligned, I'll follow through with some of these grade alignment, but I might not, you're welcome to encourage and explore grades and projects within different grade bands as well. It just increases in some coding complexity, but it's all great to expand with students. So let's take a look to start at our Powerful Force of the Wind lesson for our lesson library. When we arrive at our Powerful Force of the Wind or any lesson on our learning platform, we'll see that we have a lesson overview. So this is information that will help you with prep in your prep for a classroom or a unit. It's not something that the students will see when they are joining and following along with a lesson. If you've never started the lesson before, you'll have something like Start Lesson. And then we see that there's a link that we can share with students. This is super fun. It's really easy to join. We want to share with students and share that information in whatever classroom environment your school might be teaching with. So we can paste a direct link. We can also share with Google Classroom and copy that link to share. And what this is doing is it's creating a link unique to you for your students to join a lesson. If you're teaching the same unit in future semesters or years, this link won't change. So you prepare it once, and then you get to forget about it, and the students will have access to that lesson link. This is really great, especially for school boards. There's no student logins required. Only educators are logging in for all of this free content, and then we're sharing that link to students. The other thing that we can take a look at when we're exploring that lesson library is some of the content in our project overview. So this is great to give us an idea about what we're going to expect on the platform and within the lesson. We see that we have learning goals for our projects. Either the Coding for Good kit or the Climate Action kit works with this project. And then we have this tab called Prep or Preparation. In this area, we'll have materials that have an example. We need to make sure for all of the content within Forward's learning platform that we have a computer with access to MakeCode. That's where we're going to code from. And then there's some recommendations if you want to brush up on some of the content as an educator to get more confident with some of the content within the lesson. So for example, we have our asynchronous educator training series. We also have specific linked tutorials to the motors or the sensors that will be used within that project. We'll take a look at that later. And then there's links to pedagogical resources related to the content in the lesson structure that was used to build much of the content for the learning platform. Our activities will give you an idea of how much time to block for different content. So in our Powerful Force of the Wind lesson, we have a big idea. We'll refresh or learn about how wind turbines are powering our community. And then our Take Action section, we recommend to be 30 to 45 minutes in most of our lessons, if not a little bit up to an hour. So we can break up that content and plan out either a one-day session or a multi-day session. Next, we have different tutorials, and there's links to final code that you can use to evaluate student work, as well as step-by-step tutorials that students will follow when they actually join that session link. In our last two sections, we've got examples if you're looking to evaluate student work for assessments. So you can evaluate their understanding of a lesson content, both for a subject-specific knowledge. In this example, a great link would be for science or for coding comments, for example, if we're evaluating computer science. Finally, every single lesson is linked to national as well as state and provincial standards, and they're linked to the lesson alignment. So you can easily take a look at these national standards, or we can open a sheet for many, many different states and provinces to see that alignment. So I know that this is going to be a great fit for my classroom. Let's take a look at what that actual lesson looks like. The last thing that we see right before we jump into the lesson is there's a quick preview that connects lesson content. So in this lesson, we're looking at forces and renewable energy. There's a link to an external real-world example that you can use, as well as a career profile library to extend that learning. So we'll continue our lesson, or you will click start. Okay, what we see when we arrive at a lesson is an introduction. Every single one of the lessons within the learning platform are linked to a sustainable development goal that can help you to orient or extend the learning within that platform itself. When you're exploring with students, in your educator view, so you are logged in, you'll see these helpful educator notes in a yellow sticky note. Those are private just to you. When you share a student link, the students will have access to several interactive activities, as well as reflection questions that they can use to host a discussion relevant to the topic. If we wanted to jump forward to take a look at what those hands-on activities and building tutorials look like, let's get a preview of our Take Action section. So every lesson has a big idea. We recommend that you spend about 15 minutes with your class. And then the Take Action section is a building tutorial as well as a coding tutorial. There's 3 different options that you can use to scaffold with your students, and it's really up to you for what type of content you want to use with your students. You can divide it in any way you want. So they're called Use, Modify, and Create. This is a framework that was established within the education sphere, and it helps to scaffold coding principles and build confidence for new coders as well as for educators. So our Take Action section, we can follow our steps in our use phase, and we'll learn about the different pieces of code and the sensors that we're using to expand and communicate or define what those are. So I might follow a step-by-step tutorial, read the code, and then be prompted to explain what it does or to test how it works. In the modify phase, the same building tutorial will use slightly adapted code where students will be prompted to change the code block and to explain what they're changing to increase the variables or customization of their code. So you'll have something that will have a starter code that they'll shift slightly and keep explaining. In the create phase, students will have options to have just the prompts about what success looks like, and they'll invent their own model as well as their own code in an open coding environment. So this is the most open feature. In your classroom, you're able to use just one of these. You could facilitate the entire class, or students could self-select what they're comfortable with. Or you could issue a multi-day project where they start with use, go to modify in a future class, and then they go to the create phase. So it's really up to you, and it's great that it's available for every single one of the Forward Education lessons on the platform. With that, let's take a look at what that one use phase looks like. Okay, so when we're building our project, we're going to build, in this case, our wind turbine in 3 steps. First, we're going to build a wind turbine, then we're going to add code that will make it move, and then we're going to use it to learn how it works. We have examples of what success looks like. So this is really helpful to evaluate students on some of their work. The students would then click Let's Build, and we're going to open our coding tutorial that will show us our step-by-step building steps. In this platform, you'll be able to see a final model of what that actually looks like for what the students are building, and we'll be able to have access to pre-built code that the students will learn and be prompted to interact with. There's a step-by-step building tutorial for every one of the lessons on the learning platform, and they're all compatible with both the Coding for Good kit and the Climate Action kit. So we would have our building steps as we go through, and we would build those blocks live. I'm going to progress through these blocks, and we'll take a look together a little bit for what we can use with those sensors and how to connect it. So this is great to see if you're nervous or new to coding. We recommend these building tutorials, and they're all created by Forward Education, and they're custom linked to the content within that lesson. Once we've built a model, we're going to code with our project. So we'll have a prompt. The students will get reminders that you can help to facilitate within the classroom about how to connect their project. And they'll have an animated instructions about how to download their code itself. Okay, so if we downloaded our project, we'll just take a look at what this tutorial looks like in our environment here. When we're looking at our wind turbine, we'll have some type of inquiry question that students will use to describe the pieces of their model. So for example, if they're looking at the parts of their project, they'll describe what represents pieces for the wind or the pushing forces, and they'll verbally respond or respond in writing, where you can evaluate that at a later time. When they click the Tell Me More, there's a sample of the actual response. So in this example, our wind turbine has a dial, and when we turn our dial, the circular block is going to turn like our wind turbine. So you can describe what that real-world hands-on model is representing to the concepts that you explored within the prior lesson. If we click the next phase, we can see an example of what a hint looks like. In this example, students are encouraged to look at the code in the workspace and describe what they think is going to happen before they try the code. So we can read our code block and see that it says in English, on dial turned by, and then there is an arrow and the word difference. The other example then we'll see is we will set the middle servo to 50%. So students would describe what they think that the code block does in this one piece, and then they could describe what they think the second part does, where it says on touchdown, set middle servo to 0%. Our hint icon will show what an example of the block looks like related to the description. So in this example, students are describing what this one code block looks like. We'll say, tell me more. And we'll learn that when we turn the dial to the right, which is clockwise, the green block will start to turn. And we will have an input and an output. So we're reinforcing some programming concepts as well as links to our science concepts that are aligned in this lesson. Students would progress through with the use tutorial as well as exploring and testing their model as they follow along with these steps. When they're done the tutorial, they can exit and they can choose to explore another modify or create tutorial, or they could jump into a custom expansion that you might issue where they might modify on their own outside of that lesson. So it's really up to you. So that's what a lesson looks like and where we find lessons within our learning platform. Once I complete my tutorial, I can go and take a look at the next section. Here's where you would get a link to our modify tutorial for students if they want to continue scaffolding, as well as the final page where we have our create. The create phase has really great connections to other resources within the ecosystem that Forward Education has on our learning platform. So for example, we have a scaffolded design journal template where students can use brainstorming and engineering design process to actually fill in a digital template you could choose to print, and they can talk about the steps where they design their model as well as their code throughout their journey. And they would align some of their criteria to the success criteria listed. Another great example of a resource within the create phase is every single lesson has a linked career profile that has examples of career trajectory, what the industry is doing, what that actual career does, as well as links to real world interviews with people from those careers who have pursued post-secondary education to actually get those careers. So we'll click on one of those links now and see what that looks like. So our career profile overview, there's lots of different responsibilities. So there's tons of resources that students could explore as a research project embedded on Forward Education's learning platform, as well as links to external resources if they were going to seek more examples or information about the education. This is an example of a role model. So there's an interview as well as links for our partner with Connected North to explore more examples with Indigenous role models in specific sectors. All of these resources are linked on our career file library that we can explore tons of different examples and search in that library as well. So if you are looking specifically for links to construction industry or different projects, you can find that on the career profile library and look for projects related to these links as well. So there's lots of different ways for you to teach or find content that's relevant to you. All right. So we have successfully explored how to log into our platform, where to share links with students, as well as how to access all of the free resources on our lesson library and career profile library. I want to show you some other libraries and as well as how to actually connect your breakout board and download code to your project for the first time. So let's go back to our dashboard. Remember that when we log in for the first time, here's the window that we're going to keep seeing. The educator resource library have links to those embedded content. So like that design journal that I mentioned, if you're looking for that, it's a great spot to go. The last two places I wanted to mention is projects as well as tutorials. A tutorial is great if we want a reminder for what one sensor does and what one code block will do with that sensor. You can open code that's embedded into those actual tutorials and watch videos or look at what that content does live. So it's a really helpful reminder to look at what those one component does, or for students to explore if they want to learn more about the specific sensor related to that topic. A project uses one or two sensors and will have a building tutorial in many cases where you can build a real world project as well as have embedded modifications where you can extend your learning. Let's click View All, or we can navigate to this project library. The same way as our lesson platform, we have a product that we can filter by. So let's take a look at our Climate Action Kit projects. So we can see that there's lots of different examples that we can code with and use. There's also expansions if we want to connect to STEAM and put some art and design into some of the existing lessons that you have. And you can explore different components within the Forward Education ecosystem. So we can see here that in this turbine speed indicator, this is actually an expansion of the lesson that we took a look at earlier, where we can learn about affordable and clean energy using another one of Forward Education's sensors, and we can see how we'll prepare for that project. So we'll have a hands-on step-by-step build embedded into our project, as well as finished code that we can open and see live how that will work. Finally, there's an area for us to improve our model and to modify or make that our own. So in addition to the curriculum aligned lesson library, there's different projects that can be expanded and implemented within your classroom. Now, if I was interested in this code and in this project, and I'm getting familiar with Forward Education's library, I want to take a look at a tutorial first. I want to make sure that I know how to download code and run my lesson before I get started. So for some of my prep, I'm going to say, I'm really interested in this dial. So let's take a look at what that dial tutorial looks like. This hyperlink is going to bring us to our tutorial library. We can go right into it and look at what that looks like. So on our tutorial, we see that there is a dial component, and there's a video that's going to show us how to do it. I'm actually going to encourage you to bring out your climate action kit, and we'll take a look live. So we'll go back to our slides for a moment, and we're going to take a look at that breakout board and what our dial does. Okay, so what we're going to do next is explore our sensors, our building blocks, and our motors, and what our motors do. Then we're going to be able to figure out how to see a simulator in MakeCode and how we're going to download and create our first project. So our breakout board and our microbit are what is powering these sensors. So we can see that our model and our microbit is connected to our breakout board. So I'll take a look and show you the additional breakout board here. So this is our breakout board. We've got a bit of a green screen on, so we have a green globe when we take out our kit. So it's at the top of the lid, it's a circular globe here, and it's able to connect to our microbit. So the microbit is what is powering, it's kind of like our brain of the project. And then our breakout board is able to extend with sensor capabilities. There's different ports that we can plug and play into the actual sensors. And all of the cables are reversible, so it's really easy for you to plug in. So if you have your climate action kit or your Coding for Good kit nearby, take a look at what that breakout board looks like. Some really key things when we're looking at our breakout board or when we're teaching students is where we're going to plug in different sensors to. There's 4 options for you to plug in sensors, and there's a really handy icon on the breakout board itself, as well as on our components. So our Coding for Good kit sensor, or our climate action kit, has a dial. That was the tutorial we were looking at earlier. And my dial looks like this. So I can see that on my dial, there's the word dial and a sensor icon that we can plug into. The bottom of our breakout board has motor ports. And that's where we're going to make anything that spins connect. It's important to note that our motor ports are able to be programmed specific to a left, middle, and right. So we can also see that they're on our breakout board. There's an etched L, M, and R. That will help us when we want to make a project like a car to drive one motor in one direction and one in the other, so it doesn't spin in a circle the whole time. The other thing on our breakout board is something called a pump port. So this black port on here, you can take a look at. That plugs into our pump, which we can use for projects like plant watering, or we could, we've got lots of really great projects to learn about how sea level is rising, as well as a flood alarm are all great examples of our pump port and our battery power. So there's a switch in the bottom corner of our breakout board. That switches on, and then we'll see that there's a light that will turn on to our breakout board. When our breakout board power is high at full battery, our light will be green, and when the power is low, it will flash red. It's important to make sure before you facilitate a session, we recommend that you charge your breakout board so that it will have power, but this is able for us to download code to our microbit, and actually take it out into the real world without having to be connected to the computer. So this is powering our whole sensor. With our microbits and our breakout board, we can plug and play and actually use those simulators in MakeCode. So in our kit, in the bottom, we have these reversible cables, and that's how we're going to connect super easily to our sensors. So I've got a cable can go into any one of our sensor ports, and then I'll connect my cable into one of my sensors. In this case, I've got my dial. And we can actually daisy chain or connect, like in our photo, to power more sensors off of the breakout board and that sensor itself. So it's really easy because you can click and put them onto a like green, onto a building block that comes into your kit. I like plugging my sensors in when I'm testing for the first time, just onto the board itself, and expand some of those capabilities. So now I've got ready to go those building blocks onto my green board, and I can expand and plug in something else if I want to. There's lots of sensors that come in your climate action kit, but if you have another one of Forward Education's kits, all of those sensors will all be powered by that one breakout board. So you can combine everything that you have and use whatever you want with whatever project. When we're taking a look at the climate action kit, the sensors that we haven't talked about yet, as well as that are in the Coding for Good kit, are listed here. So we looked at that dial. It's also, we've got cool LED ring that students really like. So you can use that to make your sensor, your project, any color that you want, either the whole circle or individually. So this one's really popular with students. That's the LED ring. There is a touch sensor that you can use to be another button. There is a sonar sensor. So that says, how far away am I from something? This is a great project when we have a vehicle. It will stop when it's going close to something. There's also a line sensor. So that sensor is a little ball that has, it's used in a vehicle project to follow a black line on against a white background. So a car can drive along an area like an autonomous vehicle and actually go and navigate through a warehouse. We talked about our touch sensor. The solar sensor will detect how much light is in a room and actually be able to control something like a light to turn on and off, depending on how bright it is. And then our sensor is the last sensor I haven't talked about. Our moisture sensor is able to detect how moist is water or the flood alarm. So it's really great to combine with the pump to create an automatic watering project, or something like a sump pump where you'll detect flooding and then move the water away from that area. Finally, we've got two different kinds of motors from a specific position called a positional servo motor and a continuous servo motor. So they'll spin all the way around, like in our wind turbine or any of the car projects. All right, so let's take a look how we actually use this sensor in MakeCode. Our breakout board, we were looking at our tutorial for our dial. There's an example of MakeCode blocks available that you can actually use to test this code. MakeCode is the platform where we actually program our models. So this would be an example if you wanted to introduce a concept to students. In the classroom, they could take a look at this tutorial, or it's great for you to learn asynchronously as a preparation beforehand. We're going to click this button to open our code in a new window, and this will allow us to actually edit and download the code itself. I have my breakout board here, and I'm going to be connected to my dial from my sensor port for this project. This is MakeCode. We took a look at what that looks like earlier. In this environment, you get access to all of the blocks that are available for the Climate Action Kit and the Coding for Good kit. If we wanted to add this extension on our own, we can also search for the extension itself to get access to blocks from other kits or other expandable pieces with the microbit. Forward Education's blocks, we have sensors and motors in this example, and you can drag and drop them all into that platform. We have the dial here, so we can see that all of our components have a little underlined dial, so they're all sorted by those things. So let's just download and plug in the code. What we're going to do for the first time, if you're following along, is we'll take a micro USB cable. There's one that comes with your microbit, and we're going to plug that into your computer. I'll plug one other end of it into the top of your breakout board, like so. So we're plugged into our microbit. Now we can see that I have connected the breakout board to my computer, and now my simulator is actually displaying live. So what I mean by that is when I turn my motor or my dial will respond on my computer as well. So what you can do is we can click download code, and your simulator will pop up in real time. So whatever sensor is plugged in will allow you to actually connect to your model and to see what data is connecting live. Okay, so what this code does is when I turn my dial, I will show a number on my microbit. And when I press the A button on my microbit, I will display the number of times I've turned my dial divided by the times I have turned the full click. So it will show me the percent value of my turn. And when I click my dial, it's going to show a heart. So I've downloaded my code. I'm going to show what my microbit actually does on my display here. So I've got my code right here. So when I click down, I should have a heart icon that displays. There we go. So if I wanted to add any of the other sensors to my project, then I could add them right here in my code. So I could add something like LED lights and say when I click my touch sensor down, we'll set all of my LEDs to the color red. And I could really quickly just plug that in too. So we'll click and connect our actual sensor. So I've got my LED ring, and then all I have to do is click download again. So we'll have that downloaded. And when I click, my light has turned on red, and I've got my heart. So that's a bit about how we actually connect our microbit with our climate action kit or our Coding for Good kit for the first time, and where we find our resources on the learning platform. All right, so if we wanted to look for more resources, there's a knowledge base available that you can ask any questions. There's lots of great examples like how long does my battery last on my breakout board, as well as other commonly asked questions. Asynchronous educator courses, as well as educator resources are also available. I would recommend for people who are getting started, take a look at a project or a lesson that is interesting to you, and just take a look at the tutorial related to the sensor itself. Test it out once or twice maybe before you run it for the first time in your classroom, and then you're good to go. You could also just show students the lesson library using your view, like you could screen share the lesson library, and you could encourage the students to pick a lesson that they might be interested in, and you could share the link to that lesson for them as well. So that discovery along with the students as well is something that we see a lot in different classrooms. I would love to know if any of you have any questions. You're welcome to unmute or type them into the chat as well. I'm happy to show any specific sensor, motor, or resource that we have on our learning platform with you as well. thank you so much, everyone, for joining today. And I hope that this has given you some inspiration to start with.